All right, so this is our final lesson of the year, and again, it's 66. This is exponential function integration. So if you thought that taking the derivative of e to the x and e to the u was easy, well, then you're going to think that the integrals are just as easy. So you are integrating, again, anything with base e, the natural exponential, not to be confused with ln, which is the natural log. So from here, if you are integrating just e to the x, again, it's an x and nothing else, then it integrates as e to the x. And then, of course, because it's an integral, you're going to finish it with a plus c. If it's anything other than just an x, you have to instead think of it as a u. The integration of the e to the u is e to the u. Keep in mind that if you're doing u's, you still have to use your friend u substitution. You probably will enjoy this more than yesterday because, again, you guys seem to be really good at u substitution. We've done it now for several months, and now we just have to apply it to our exponentials. So on the front here, you're trying to get down to one of either of those, e to the x or e to the u du. So find and simplify each indefinite integral. Again, focus on the word indefinite. All of these are going to end with a plus c, and those are the ones that we're going to do. There are no definite ones for today. So consider number one, the integration of 2e to the x dx. This e to the x dx, that's the dream. That's as easy as it can get. That 2 on the outside is literally just a constant, so you don't have to do anything with it other than bring it down for the ride. So once you realize you have e to the x dx, you can just jump right to the answer. When you jump right to the answer, leave the 2 out front. Again, that's just a constant. The integration of e to the x is e to the x, and then finish it off with a plus c. Remember, the reason why the dx and the integration symbol disappear is because you've applied the rule. So once you apply the rule, it is no longer there. So if you have just e to the x, it integrates as just e to the x, and then, of course, any constants. Compare that to number 2. Looks similar, but you're going to approach it quite differently. So 2e to the 2x dx. Look up what's in the exponent, this 2x. If it is anything other than just an x, you have to call it u. So just like we've been doing now, set it equal to u. Derivative of u du. Derivative of 2x is 2 dx. And then go ahead and solve. It's possible some of you can kind of, do that in your head almost at this point. We've done so many of them. So you're going to replace the pink u with the pink u, the blue dx with the blue dx, and then the 2 out front. Remember, that's a constant. That is still there for now. It may or may not cancel. When you go ahead and rewrite this, you have the yellow 2. Then next to it, you have e to the u. And then for dx, you have du over 2. For these problems, again, I only chose the relatively straightforward, easier ones. So for today, all of the variables should cancel, so you don't have to worry about any remaining x's. Not only do the variables cancel, but in this case, the 2's also cancel, which means all you're left with is the integration of e to the u du. That is the second dream. If you can't get e to the x dx, you want to get e to the u du, which is what you have. So per the formula, the integration of e to the u du is just e to the u. And in your final answer, put your u back in and finish it with a plus c. If you've been comfortable with u substitution, which honestly 99% of you have been, I really don't anticipate you having any issues at the end here other than maybe just a lack of motivation, which I could understand. But take a look again at the first 2. Hoping for e to the x dx or e to the u du. As long as you can get down to one of those, you can use these rules. If you're not able to get down to one of those, then you have to use the old rules. So any questions on 1 or 2? Again, it's probably only 15, 20 minutes. So if you're ignoring me now, you're going to have questions later. So I would try to, again, just listen. The rest of the period will be yours. Alrighty, so e to the 3x plus 1. Again, as soon as you recognize anything other than just an x, you have to make that your u. Derivative of u du, derivative of 3x, 3 dx, and the derivative of a constant is always 0. Divide. You are going to sub in your u. You're going to sub in your dx. When you go to do that rewrite step, it becomes e to the u. Dx is equal to du over 3. That 3 on the bottom doesn't cancel. Not only doesn't it cancel, but you have to remember it's actually a 1/3. So I would probably encourage you to move to the front. The 1/3 out front, perfectly fine, as long as you can get e to the u du. That's how you know you're good to go and integrate. So when you integrate, leave the 1/3. E to the u integrates as e to the u. If you have to show that step, great. If you can jump right to e to the 3x plus 1, then even better. Do it in 1 step or 2 steps. Really up to you at this point. If you wanted to check that this was correct, you would take the derivative, which is what you learned yesterday. The derivative of e to the u is e to the u times the derivative of u. So e to the 3x plus 1 times 3 would simplify with the 1/3 to give you back to the original problem, which is exactly what you're looking for. Questions on the first 3? The next 3 get just a touch harder, although really not by much. But any questions on the first 3? Okay. In number 4, you've got quite a whole lot going on here. I don't really like the fact that this is a fraction. So I'm going to take that and I'm going to move it up to the top. How do I do that? Make it a negative exponent. So this now becomes e to the x plus 5 to the negative 10. So I'm moving it from the bottom to the top. All 3 of those things are now on the top. 3e to the x, dx, and e to the x plus 5 to the negative 10. If you compare this to the previous 3 problems, obviously it's fairly more complicated. If it's not just e to the something, if it is just e to the something, then your u is the something. If there are multiple pieces, then your u is the innermost part of the more complicated piece. So looking at 3e to the x and looking at e to the x plus 5 to the negative 10, hopefully you would agree that to the negative 10, that's the more complicated piece. So when you go to pick your u, go as far inside as you can. So that's going to be your u. Derivative of u, du. Derivative of e to the x, that's what we learned yesterday. Derivative of e to the x is just e to the x, dx, and then 0. Divide. When you now go to substitute, you're going to substitute in your u, of course. Don't lose your 3e to the x, and then replace your dx. When you go to do the rewrite step, it's the pink times the purple. I guess I'll put that last. So it's the pink times, when you do this step here, this becomes u to the negative 10. And then when you plug in your dx, it's du over e to the x. So again, replace the pink with the pink, the blue with the blue, the purple with the purple. How do you know that you're doing this right? Well, e to the x's cancel. What I've kind of been advising you about as you were doing tests and quizzes is that if things don't cancel in that step, then it's likely that you've chosen the wrong u. So if the e to the x's didn't cancel, that would be a clue to you that you have the wrong u. But after you cancel those e to the x's, this is now the integration of 3u to the negative 10 du. You have to be careful because now it is no longer an exponential problem. Now it's a power rule problem. So here's a reminder of the power rule. If you're integrating something raised to an exponent, remember you're going to raise it to the 1 higher power, and then you're also going to divide by that power. So if you're integrating this guy right here, you're going to leave the 3. What's 1 higher than negative 10? Negative 9 divided by negative 9. And then you just have to make sure that you very carefully give me the answer. The answer is going to be a fraction. The first part of your answer is 3 divided by negative 9. You can simplify that to be negative 1/3. Doesn't matter whether the negative is on the top or the bottom, but it is considered more proper on the top. Then you have to take this negative 9 and you're going to move it to the bottom. So you're now going to get something to the 9th. As far as what the something is, it's whatever u was. So e to the x plus 5, and then end it with a plus c. So kind of nice at the end here that it really does kind of go full circle and bring back some of the old integration rules, some of the power rules, some of the sine, some of the cosine. But negative 1 over 3 times whatever the u was to the 9th plus c. Again, the problems that I chose for this final homework, very easy, very straightforward. Again, if you don't have things canceling, it means you picked the wrong u. So perhaps you'll try again. Finally, the last 2 problems of these formulas are 5 and 6. Look at them carefully before we do them. Both of them have e's, both of them have trig, but because of the way they're set up, you actually do approach them quite differently. So consider first number 5. I see two things here. I see the sine, and then I see the e. If there are two things, you're going to choose your u based on the innermost part of the more complicated piece. So the more complicated piece in this instance is the e. The inside piece is considered to be the cosine, so that's what's going to be your u. This is a definite example where if you chose a u and you went to set it up and you got a whole big mess, that's how you would know that perhaps you've chosen the wrong u. So the innermost part of the more complicated piece is the cosine. Derivative of u du. Derivative of cosine is negative sine. Use your green sheet as needed. And then divide. When you go to do your substitution, it becomes the integration of the original sine that was still there. Then e to the u, followed by dx, which is du over negative sine. Feeling really confident that I'm doing this correctly because the signs cancel. Don't lose that negative on the bottom. I'm going to just move that negative to the top. And remember, you're totally allowed to do that because negatives can float from top to bottom or out front, whichever you prefer. That's it. That's what we love. We've made this complicated looking problem down to a nice simple integration of negative e to the u du. When you go to integrate, leave the negative. The integration of e to the u is just e to the u. If you need to write that step, then do so. If you can jump right down to e to the cosine, even better. And again, don't forget a plus c. Questions, questions, questions? Okay. Last one of this type then, over on the right. Again, there are e's, there are cosines, but you need to be careful when you're choosing your u. This is considered to be the first term. This is considered to be the second term. When you have multiple terms, your u should be the innermost part of the more complicated piece. So in this case, the cosine is the more complicated piece, which means your u is going to be e to the x. So u equals e to the x. Du, remember the derivative of e to the x is just e to the x, dx. Divide. Go ahead and rewrite it. This becomes the integration of the original e to the x times the cosine of u times du over e to the x. Again, it should be abundantly clear that you are doing this correctly because the e to the x's are now out of there. And it becomes the integration of the cosine of u du. Again, notice that this is no longer an exponential problem. This is a cosine problem, which means you now need to go back to your cosine formula. So again, I have it right here for us. It's also in your green sheet. The integration of the cosine of something is the regular sine of the same something. So the integration of the sine of u, the integration of the cosine of u is the sine of u. Make sure you actually plug back in what u is equal to. So sine of e to the x. And then, of course, plus c. So that is how you integrate any exponential with a natural base. Just like yesterday's lesson, the 6 homework problems only have to do with this front side. Again, things with e's and ln's do tend to be more common and more preferable when you get to higher level calculus, if you plan to go that route. To finish us up then, our final 3 problems of the day, of the week, of the year are on the back here. So the final 2 formulas are how do you integrate an exponential with a base other than e. So how would you integrate 2 to the x, 5 to the x, 10 to the x? So anything other than e. Again, no need to memorize 2 final formulas. If you're integrating a to the x, you are going to integrate it as 1 over the ln of a times a to the x plus c. And if instead of being a to the x, it's a to the u, it's the same exact formula, except you're going to be using u's instead of x's. And again, for this one here, you're going to continue using u substitution, which has served us so well up to this point. So our final three problems, again, find each indefinite integral, use u substitution as needed, and again, because they are in fact indefinite, don't forget to finish it with a plus c. So number 7 here, it's the integral of 2 to the x dx. Hopefully you realize that that is a to the x. Again, a has to be something other than e. So if you're going to integrate this using a to the x, you probably also want to know that a is equal to 2. That's this formula right here. So all you have to do to solve this is plug the variables in where they go. So per the formula, when you go to integrate, it's 1 over the ln of a. So 1 over the ln of 2. A is 2. Parenthesize that. Then times a to the x, which is just 2 to the x. And then plus c. Literally just a formula. Don't be freaked out by how easy or difficult it looks. It's literally just a formula. No simplifying to do. You can't cancel those two, so you're good. Perfectly fine if your answer looks messy. Then for number 8, the integration of 8 to the negative x dx. Hopefully you could include that this is not a to the x, but instead it's a to the u. In this particular problem, a is 8. And then again, you're going to use u substitution. So your u is negative x. Derivative of u, du. Derivative of negative x is negative 1 dx. Divide. All that work to just go ahead and do the rewrite. So when you go to do the rewrite, you now have 8 to the u. Your dx is equal to du over negative 1. Remember, just a negative can float from top to bottom or out front. So I'm going to move it up to the top. And you're ready for your final step. And again, for your final step, you are using this formula right here. So when you now go to finish, don't forget the negative. That has to be part of your answer. Then per the formula, you're doing 1 over the ln of a. So negative 1 over the ln of 8. Again, the negative comes from the u substitution step, and the ln of 8 comes from the formula. Then you're going to multiply it times 8 to the u, which of course is negative x, and then plus c. Again, there is nothing to simplify. You don't need to. You don't need to get rid of that negative exponent. You don't have to worry about that negative number. Nothing else needs to be done for that. Questions? I appreciate you hanging in there. And again, our last problem of the day, week, year is 9. So the integration of x plus 4 times 6 to the x plus 4 squared. This is the first term. This is the second term. If there are 2 terms, you're going to pick u as the more complicated piece, the furthest inside you can go, which would make this your u right here. So your final substitution, u equals x plus 4 squared. And again, over on the side, you are going to integrate this as a to the u, where a is equal to 6. We're again using this formula here because it's a u instead of an x. When I now go to take the derivative of u, you're going to bring down the 2. Take the x plus 4 to the 1 less power. Derivative of the inside is just 1, and then dx. Sorry, it's du. Divide. And then go ahead and substitute in u for u. This is still there. Pink for pink. So this becomes the integration of the original x plus 4 times 6 to the u times du over 2 times x plus 4. Again, should be abundantly clear and obvious that you are doing this correctly because the x plus 4s do in fact cancel. When those x plus 4s cancel, don't lose that 2 on the bottom. Remember, it's really a 1/2. So in your final step, using the formula up top but to the right, leave the 1/2. Then you're going to do 1 over the ln of a, so 1 over the ln of 6, times the integration of 6 to the u is 6 to the u. And then to finish it up, take this and just put it together in a fraction, 1 over 2 ln 6. Put your u back in, x plus 4 squared, and don't forget plus c. Done with the formula sheet, done with the day, done with the year. No applause? Oh, sad. Okay. Oh, thank you. All right, let me stop the recording.